This says first principle and sum and differences of functions of x. Alright, so let's have a look at example 18. It says, given that f of x is equal to 4x minus 6, show using first principle, so that is the the derivative definition, show that f prime of x is equal to 4. Well, first of all, f of x is equal to 4x minus 6. And f of x plus h is equal to 4 times x plus h minus 6. So to find f of x plus h, in f, wherever you see x, you're going to take out x and put x plus h. So let's expand this. This is 4x plus 4h minus 6. So from first principle, f prime of x would be equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So this would be the limit as h approaches 0 of 4x plus 4h minus 6 minus 4x minus 6 all over h. So f prime of x we're going to have is equal to f prime of x is equal to the limit h approaches 0 of 4x minus 4x plus 4h minus 6 plus 6. All right, and this is all over h. So f prime of x is equal to the limit of h as h approaches 0 of, well, 4x minus 4x this goes, minus 6 plus 6 this goes. So what we have is what? Positive 4h over h. The h is cancelled. So this is equal to the limit as h approaches 0 of 4. All right, and from since there's no h, f prime of x is now equal to just what? 4. Because as h approaches 0, doesn't affect a constant, which is 4. So the limit as h approaches 0 of 4 is 4. All right, example 19. In example 19, we are told, given that f of x is equal to x squared plus minus 2x plus h, we're to show using first principle that f prime of x is equal to 2x minus 2. All right. First of all, again, f of x is equal to x squared minus 2x plus 3. Now, f of x plus h, this would be equal to x plus h squared minus 2 times x plus h plus 3. So again, anywhere in f I see x, I take out x and put x plus h. If we expand, we're going to get x squared plus 2xh plus h squared. Distributive law here, minus 2x minus 2h plus 3. Now, from first principle, f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. So this is the limit as h approaches 0 of x squared plus 2xh plus h squared minus 2x minus 2h plus 3. All right, this is not my whole. So let's erase it and go below instead. So this would be equal to the limit h approaches 0 of x squared plus 2xh plus h squared minus 2x minus 2h plus 3 minus x squared minus 2x plus 3, and this is over h. All right, so we can see when we apply distributive law to the right, you're going to have x squared minus x squared. So let's spell it out. So this is the limit h approaches 0 of x squared minus the x squared to the right. All right, plus 2xh, there's no other term in, plus h squared minus 2x to the right. The one negative times a negative is a positive 2x minus 2h plus 3, and to the right a negative times a positive 3 is minus 3 all over h. I wonder if I have any space to the right. Well, we can see clearly that that goes, or any space on the next page. This goes, this goes. Let's see if I have any space. Next page. No, I didn't provide any space for it. So let's finish it on this page. So, let's put it up here. So, I can start from down here. This is equal to the limit as h approaches 0 of 2xh plus h squared minus 2h over h. Alright, so this h cancels this h here, cancels one of this h, and cancels this h. So this is the limit as h approaches 0 of 2x plus h minus 2. Alright, so by direct substitution, we're going to get what? 2x plus 0, because h is 0, minus 2. Alright, so we managed to finish. Example 20. Alright, example 20. Alright, wonder if we should have done this exercise, but it's too late, so it's there already. Let's do it. By first principle, we have what? F of x plus h, because of f of x is already, is equal to 1 over the root of 2x plus h plus 1. So this is equal to 1 over the root of 2x plus 2h plus 1. From first principle, the first derivative, f prime of x, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So this would be equal to 1, the limit as h approaches 0, 1 over the root of 2x plus 2h plus 1 minus 1 over the root of 2x plus 1, and this is over h. Alright, now we could then say now that f prime of x is equal to the lim as h approaches 0. At the top, let's find the LCM. The LCM would be the root of 2x plus 2h plus 1 multiplied by the root of 2x plus 1. Alright, and at the top I'm going to have the root of 2x plus 1 minus the root of 2x plus 2h plus 1. Interested? And this is all still over h. If I wanted to, I'm guessing that I could probably then multiply the top by multiply the numerator and denominator by the conjugate, multiply the numerator and denominator by the conjugate of the numerator. So that is still at the top. So f prime of x could be equal to the limit as h approaches 0, 2x plus 1 minus the root of 2x plus 2h plus 1 multiplied by the root of 2x plus 1 plus the root of 2x plus 2h plus 1, and this is all over the root of 2x plus 2h plus 1 multiplied by the root of 2x plus 1 multiplied by the conjugate of the numerator, which is 2x plus 1 plus the root of 2x plus 2h plus 1. Alright, at the top, you're going to have the difference of two squares. So this is going to be the lim. Ooh, before we get there, getting ahead of ourselves. Alright, we should have put this, and this is still all over h. So this is going to be equal to the lim as h approaches 0. And at the top, we're going to have what? 2x plus 1 minus 2x plus 2h plus 1. And this is over the root of 2x plus 2h. This is the root of 2x plus 2h plus 1 times the root of 2x plus 1 multiplied by the root of 2x plus 1 plus the root of 2x plus 2h plus 1, and this is still all over h. Tedious. But let's keep going. At the top, we're going to have what? The limit as h approaches 0. So we're getting tired of it. So we can see the 2x minus 2x that gone. Plus 1 minus 1 that's gone. So at the top, I'm going to end up with what? I'm going to end up with minus 2h at the top. And this is all over the root of 2x plus 2h plus 1 multiplied by the root of 2x plus 1 multiplied by the root of 2x plus 1 plus the root of 2x plus 2h plus 1, and this is all over h. Alright, actually this h here and this h here is going to cancel. So if we apply now direct substitution, I'm going to have minus 2 at the top. Direct substitution. And we're going to have at the bottom the root of 2x plus 2 times 0, which is 0, plus 1, multiplied by the root of 2x plus 1, multiplied by the root of 2x plus 1, plus this is what? The root of 2x plus 1. Because remember, direct substitution, we're going to put h as 0. 2 times 0 is 0. So that h term disappears. Alright, this is what we have so far. So what we have here is minus 2 over 2x plus 1 multiply by 2 times the root of what? 2x plus 1. This 2 here cancels this 2. So what we have is minus 1 over 2x plus 1 to the what? 3 over 2. Alright, so that was very tedious. Took about 10 minutes to work that. So let's go back to what we have at the top. And this is exactly what we had at the top. So it worked out. This is something that you could try to see if you could work it out as well. Alright. You need to practice, so you should do it. Alright. Finally, the last part. This says rate of change. Now, a function is said to have a rate of change at a point A if the derivative of the function exists at x is equal to A. Alright. In other words, from C-Sec, if you remember, when someone says rate of change, is graded, they're actually talking. So when someone says find the rate of change of y with respect to x, what they're asking you to find is the what? is the gradient, and if what they're asking to find is the gradient function is the first derivative. So in a sense, they're asking you to find the first derivative. So example 21 says find the rate of change of y with respect to x, given that x is equal to 1 and y is equal to 4x cubed minus x squared plus x plus 2. So the rate of change, which is dy by dx. So dy by dx is telling me y is changing with respect to x. So dy by dx is the rate of change of y with respect to x. So 3 times 4 is 12x, and you decrease the power by 1, minus 2 times x, and you decrease the power of 1. When you differentiate x, you get 1. And when you differentiate 2, which is a constant, you get 0. So the last thing I'm going to say is I'm going to say when x is equal to 1, dy by dx, which is the rate of change, is going to be equal to 12 times 1 cubed minus 2 times 1 plus 1. Now, 1 raised to any power is still 1. So this is 12 minus 2 plus 1. So when x is equal to 1, the rate of change of y with respect to x is equal to 12 minus 2, which is 10, plus 1, which is 11. Very lengthy.